Welcome and thank you for joining us today. My name is Brian Warwick. I'm a Senior Partner Solutions Architect for Healthcare and Life Sciences here at AWS. And today I'm joined by my colleague, Harvey Ruback.
And my name is Harvey Ruback. I'm also a Partner Solution Architect in the Healthcare and Life Sciences vertical. Been with AWS just over 2 years, and I've spent the last 6 to 7 years helping customers connect their medical devices to the cloud, bring their data in, and then what they do with it after it's there.
Just like Harvey, I come from healthcare as well. And as PSAs who have the privilege of working with our healthcare and life science partners, we often hear about some of the biggest challenges that customers face today. One challenge in particular is how to go about building interoperable and real-time clinical applications on AWS in a safe and secure manner. Healthcare organizations are complex, with multitudes of systems that all have to work together in order to create the best patient, clinician, and employee experience possible. This complexity and the numerous systems and amounts of data that are generated have over time led organizations to developing massive silos of data. So let's first take a look at how we got here. Nearly every healthcare organization today most likely has some form of electronic health record system where they use this as the primary source of truth for all of their patient data. That EHR has a series of servers and databases that power it. Now, perhaps over time, an organization went out and purchased a patient portal solution with its own set of servers and databases. Then the organization went out and purchased maybe a telehealth solution with more servers and more databases. And then maybe a department came along and purchased a specific solution used for clinical decision support, again, with more servers and more databases. Then everyone started looking at this data, and they figured with all of this being generated, we should probably do some machine learning on it. So maybe you went out and purchased some SaaS machine learning solution where the data is copied, de-identified, and then sent via maybe SFTP to another entity where more decisions are made on that data. And over time, as you continue to bring on new solutions to your organization, you can see that it gets pretty complicated. There's a lot of data being generated. And this creates a problem where you have so many inconsistent data models in multiple locations and these monolithic solutions. So the question is, how do you begin to align on a common data model where you can bring all of this together in a centralized place and create an environment where you transition from your organization into a more secure place where you're able to empower your clinicians and patients and improve the experience for everyone? The first thing we need to do is normalize on a common model when possible. And this is not just for building machine learning models, but it's also about knowing what to expect when you access that data and how to go about getting access to it. In healthcare, to solve that problem, we often talk about interoperability. And we have here the definition of interoperability. I'm sure many of you have seen this today. But one key point we want to call out here is highlighted, the fact that interoperability is not just about exchanging information, but it's also about providing timely and seamless portability of information so that you can optimize the health of individuals and populations globally. So when we talk about interoperability, I'm sure many of you today who've worked in healthcare have heard of HL7. HL7 is an organization that has standardized how clinical systems can go about sharing information together. And a common rule of thumb in the analytics world, especially for machine learning, is you're going to spend a lot of time trying to get all that data cleaned up and get it in a place where you can do your real work. And those of you who've been around healthcare and have heard of HL7, who have worked with it, often have heard that if you've seen one HL7 stream, you've seen one HL7 stream. That even with the guidelines and the standards that are out there, there are still differences. There are still those gray areas. So determining what that data model could be when we start to break down those silos is, we often talk about FHIR, which is the next evolutionary development path for our HL7 V2 and CDA. So what are some of those advantages of FHIR? Well, first and foremost, it's very easy to implement because of the fact it follows those web standards that all of us are used to today. Data can be exchanged via JSON and XML. It's predictable. Accessing it, you'll access it using OAuth. The RESTful architecture that it provides works really well for developing a modern architecture, especially as you want to continue to go forward and innovate and build new applications on that clinical data. It's also flexible and free. And what we've been hearing from a lot of customers, especially over this past year, is that because of the 21st Century Cures Act, and this is here in the United States, the ability to provide that third-party access to clinical data, we see a lot of customers today getting data in FHIR, and now they're looking at it, trying to figure out, okay, what can we now do with all this data that we now have access to, and we know what to expect from it. So when it comes to FHIR, when we talk about FHIR here at AWS, and the idea of using the right tool for the right job, we have two new solutions here at AWS that can help accelerate your work with FHIR. First, we have Amazon HealthLake, which is a fully managed FHIR store designed to unlock insights from your clinical data. HealthLake allows you to ingest your data in FHIR, and then it automatically runs medical comprehension on the unstructured data, like clinical notes. The results of these models, things like ICD-10 codes, RxNorm, medications, diagnoses, PHI, and many more models, are also fully searchable across the entirety of your HealthLake. Now, we also have Fireworks on AWS. Fireworks on AWS is an AWS solution which allows you to stand up an open source FHIR server in your AWS account. And we have customers today actively contributing to it, and it is comprised of fully managed serverless services underneath, built so that you can provide third-party access to the clinical data that you need to, and stand up a real-time FHIR transaction data store quickly. And again, the great thing about Fireworks on AWS is because it deploys those assets into your AWS account, it's completely customizable. So you can choose how you want to go about implementing the FHIR server of your choice. Now, not everything's going to fit into FHIR. And so when it comes to breaking down those silos and getting all of your data into one place, we often talk about the idea of a data lake here at AWS. And by building a place where you can capture and bring together all of this data in one centralized place, you're able to streamline access, secure everything, and with like a service like AWS Lake Formation, for example, you can use AWS tools to orchestrate and manage about the bringing together of all of this data and providing that fine-grained access controls that you need to it. And when creating a proper data lake, while it's not just standing up more silos, it's really about bringing all of that heterogeneous data together in a controlled and orchestrated manner. This helps provide a single view across all of your data sets so that that data can be provided to the rest of your solutions. So now we can begin to break down data silos and continue to look at different types of data to drive new solutions and provide better clinical and business outcomes. So when we talk about bringing all this data together to AWS, that core clinical data set, and this can be anything from audio files, PDF documents, CSV files, your electronic health record system, all of that data on AWS, bringing it together, that clinical data set, you can actually start to build from that and create these cloud-centric healthcare applications. The other great thing about this is with your data in one place and it's secured, you no longer have to take that data, copy it, de-identify it, and take it to another system, but you can actually do your reporting and your analytics and whatever AI/ML work you want to on the data right there in your AWS account. But the important thing about all of this, before we get started and going just building things, we need to make sure that everything that we do has the security compliance guardrails that we need in place to make sure that we are building safely and securely. And so in order to talk about that more and what we'll be doing about how you can stand up those guardrails here and build securely on AWS, I'm going to turn it over now to my colleague, Harvey Ruback, to get into more details there.
Thanks, Brian. So as Brian said, I'm going to talk to you about protecting your clinical data on AWS. Now, where I want to start is that building on a solid foundation, you want to build on a foundation that supports global compliance certifications and accreditations. And you want to build on a foundation that takes security, privacy, and compliance as job zero. That's what we do here at AWS. AWS supports over 50 global compliance certifications and accreditations. For example, HIPAA. We have over 130 eligible HIPAA services on AWS. Eligible services for HIPAA are services that we have taken through a controls review and are listed in the BAA that you will sign with AWS when you are going to be creating solutions that house customers' PHI data. And you can use these services with the appropriate controls and configurations in place to meet the HIPAA controls and guidelines. Another example is HITRUST. We have over 60 HITRUST certified services. HITRUST is a standalone organization that does third-party accreditation. Now, AWS participates in their inheritance program. So if you are pursuing HITRUST and you are on AWS, when you get to the controls that AWS supports in the inheritance program, instead of you providing the information about the infrastructure, you can point to AWS's inheritance for those controls. For example, the SOC controls, because data centers are out of your control, they are part of AWS's responsibility. Finally, GDPR. Over in Europe, we have a GDPR resource center online. We are fully compliant, and you can use this resource center to do a data evaluation on your solution to determine how your solution fits within the GDPR controls and what you need to do to control your data there. Now, let me switch over and talk about the shared responsibility model and leveraging higher level services. And when we talk about the shared responsibility model, what we're talking about is what is AWS's responsibility and what is your responsibility as the customer relative to your data and the overall solution. And in general, AWS is responsible for of the cloud. We'll often say AWS is responsible for the of the cloud components. These are the things that AWS has in the cloud and has full control over. You're responsible for what you put in the cloud, your data, your software, who has access to it, how you choose to have it encrypted. And something interesting happens when you start looking across the AWS services, right? So in this example, we have an EC2 instance, right? And for an EC2 instance, AWS is responsible for the hypervisor, the virtual machine, everything that happens underneath. You're responsible for the OS that you choose to install, making sure the OS patches are up to date, who has access to the operating system, who has access to the applications that you install, and how that data moves and is encrypted. But as you move up the chain a little bit and you get to more of the containerized services like Amazon RDS, what you'll see here is the of the cloud components. Amazon is responsible for the installation of RDS, for managing the underlying operating system, ensuring all the patches are in place. You're responsible for how you access the database. Maybe it's a MySQL database. Who has access to that database? What data you put into it, how you choose to encrypt it. And if you move up to the fully managed services, and this is where Amazon HealthLake sits, you'll see that you focus on what you put into the cloud. You focus on your data, and you focus on who has access to it, and you control how it gets encrypted by supplying the appropriate KMS key that you own and manage to AWS HealthLake. And AWS manages everything beneath that relative to HealthLake, how it's installed, how the data is stored on the actual devices internally, the HA capabilities of it, etc. So as you move up to these more managed services, it allows you to focus more on the value you bring to your customers and not the undifferentiated heavy lifting of having to maintain your compliance and security for all of this data that you're bringing in, right? So as you move more data to the cloud, as you break down these silos and get them in one place, it's important to think about where you want to sit and which services you want to use to meet your specific and your customer's specific compliance needs. Now, in general, when we look at AWS, you want to build on a platform and infrastructure that gives you the highest standards for both data security and privacy, right? You can build on AWS and you can meet your data residency requirements. When we talk about clinical data, depending on the region, the data will have to stay within that individual region. And as I said before, you control where your data goes, and if and when it is ever copied or moved anywhere else. You have full control over this through how you configure your data stores, your S3 buckets, whatever they may be. We talked a little bit about encryption. AWS Key Management Service allows you to create keys, bring your own keys, and manage them, and then share those keys across the different AWS services that need to communicate with each other. And in this manner, all the data is encrypted, both at rest and at motion, based on how you configure it, and no one can view that data without access to your keys. I talked about the compliance programs. AWS complies with all local data privacy laws and how you can control that relative to the full data life cycle that you need to meet for your customers. And finally, we supply the services and the tools that allow you to build this compliant infrastructure for your solutions. Now, there is a full breadth and a lot of depth to all the different services that you can use to build your solutions. And there are pillars that align with the well-architected framework relative to best practices. I'm not going to go through all of these, but they're here for your reference so that you can look them up later. But a couple things to call out that you'll see later when we do the demo. From identity and access management, Brian's going to show you how he's using Amazon Cognito. The demo is also using AWS Config as a way to monitor the inventory, watch for changes, and then also have rules in place, AWS config rules, that allow you to get notifications and take action if those rules aren't met. And those rules can be used to help you maintain your compliance and ensure you have the appropriate guardrails in place. And then also relative to compliance, I want to call out AWS Artifact. As we said, AWS participates in over 50 global compliance programs. And through AWS Artifact, you can download the third-party audit reports and assessments and attestations that support that for ISO 27001 and all the other different ones that will be up there. Also, when you're building something in the US and you're falling under HIPAA, you can download the BAA and sign it through a self-service mechanism from AWS Artifact in your console. Right? So an example of PHI being stored in the cloud is what Philips Health Suite is doing with their Health Suite data platform, right? They are currently storing over 40 petabytes of PHI data in the AWS cloud, and it's growing at approximately a petabyte a month. These are medical records, imaging from their different devices that they bring into the cloud and make available for their customers, right? They are leveraging everything that we have relative to ISO 27001, the SOC reports, high trust compliance, in order to maintain their compliance across the board. Even today, we'll often get asked, is it safe to store PHI in the cloud? This is a perfect example of why that answer is yes. On AWS, you can safely store your data in the cloud in a compliant and secure manner. So now I want to talk about building an interoperable and real-time clinical application, right? Brian and I are going to walk you through a use case. I'm going to walk you through it up front, then I'm going to turn it over to Brian. He's going to run you through a live demo, right? And so we've been talking about bringing your clinical data into the cloud, making it interoperable, right? So what we're going to do here is we are going to have a use case where a physician, a clinician, is going to be speaking with a patient. And we're going to capture the audio of that encounter, of that engagement that they have. And we're going to take that conversation, that audio file that we capture, and we're going to make it interoperable. We're going to take the steps we need to take to put it into a FHIR resource that can then be shared with the clinician and the patient. So they'll both have access to the notes from the session and what was said. Now, we can even take this a step further by extracting the key elements that occur in this conversation and turning them into other FHIR resources that can be shared so that the elements, the details of the conversation become interoperable through the FHIR standards. For example, if we talk about a medication and the doctor prescribes a certain dosage at a certain frequency, that can be turned into medication orders as part of as a FHIR resource and shared with any downstream application that's capable and understands what a medication resource is from the FHIR standard. So basically what this is going to look like, and we'll get through further and further details as we go on, is we're going to capture this audio. The audio file is going to get saved to S3. That will end up triggering a piece of code to run in Lambda, which is a serverless technology for running code. That will get run through Amazon Transcribe Medical, which will take the audio and convert it to text. That result will then get processed by another Lambda function, where it gets turned into a document reference FHIR resource that is then put into Amazon HealthLake. And I'm going to walk you through some of the detailed sequencing that happens while this occurs next. All right. So the first thing we're going to do is we're going to capture the conversation. Right. So when the patient and clinician meet, the encounter begins. And in a typical scenario, the clinician will use their application they have in front of them on a mobile device or a computer to find that patient in the EMR, in the clinical system. And in this case, what we're showing is they go against HealthLake and pull back the FHIR ID for that patient so that we can associate the things that happen next with that patient. Right? The next thing that would typically happen is the clinician will create an encounter for that patient. An encounter is another FHIR resource, and that ID would get returned to the application so that now we can associate anything that happens with this patient to this specific visit, right? At this point, the clinician's going to start the recording. The patient and clinician are going to have a discussion. You'll see that when Brian shows the demo, and then the recording is ended. When the recording is ended, the recording gets saved to S3 in this case, which triggers a Lambda function, And as I said earlier, that Lambda function is going to take the audio file and make a call to Amazon Transcribe Medical, which is going to transcribe that audio into text, in this case, save it to another S3 bucket, which will trigger a Lambda function to run a piece of code. And what this function is going to do is it's going to create the FHIR resource that's the document reference. And when it creates the document reference, it is going to put the information into the document reference with the encounter ID, with the patient ID, the clinician ID, and build all this up. Brian will show you the details of what's going to happen in there and how the text gets stored. And then that document reference gets put into HealthLake, where it's stored in the FHIR server. Now, once that happens, in the background now, inside of HealthLake, AI/ML models are going to run as part of Comprehend Medical automatically. And Comprehend Medical is going to look and use NLP to understand the context of that conversation, right? And that data will get added to the document reference, and Brian will show you that in the demo, describing what the entities were. Was it a medication? Was there PHI? If it was medication, what was the dosage? What was the frequency? And it'll infer using those models ICD-10 codes and also RX norm codes. Once that's done, this data can be displayed back to the clinician, all of these inferences about what happened during this conversation. Now, at this point, the application with the clinician, the application can iterate over each of these items. The clinician can interact with them and choose which ones should be taken forward and made part of the medical record, part of the FHIR data store. Each of those that the clinician selects or determines are appropriate or edits can then become their own FHIR resources. Maybe it's a diagnosis, maybe it's a condition, maybe it's a medication order. Whatever these are, this is where your application comes into play to work with the clinician to smooth out the overall process. And then finally, all that data goes into the system, and it can then be shared with other applications using FHIR. So now I'm going to turn it over to Brian, who's going to take you through the details of the demo, what it does, and show you how it works.
Thanks, Harvey. Now to get into the demo. What I'm going to be showing next is a high-level reference architecture about what we actually built to make all of this happen, to go about building this real-time clinical application using our core clinical data set on AWS. You'll notice we have a mobile client on the left, and this would be used during the patient encounter. And then we built a React.js application using AWS Amplify, and our authentication for the users will be actually happening using Cognito. And then behind the scenes, we're using a series of API gateway with Lambda. What Lambda allows us to run code without servers so that we can send those job requests to Transcribe Medical and do gets, posts, and puts against Amazon HealthLake, where we're storing our clinical data set. And now, to kind of show how all this works together and see it in action, we're going to go ahead and jump into the demo now.
Before we begin this demo, I'd like to highlight the two screens here in front of us. On the left, I have a real-time clinical application built with React.js and AWS Amplify. In a minute, I'll be playing the role of a clinician who will log into this application, and I will use this to capture the conversation with a patient during an encounter. Now on the right side, I have the AWS console. I first want to highlight that we have deployed the AWS HIPAA Quick Start in this account. The HIPAA Quick Start deploys the VPCs and services following best practices for security and compliance, and this includes the AWS Config Conformance Pack that provides a set of config rules mapped against the HIPAA controls that we can modify and update to meet our specific application requirements. I'll be using the screen on the right to highlight key aspects of this solution after we capture audio during the encounter. So let's begin. I'm going to pretend that I'm a clinician, and I'm now going to log into this application on the left side. These credentials are stored in Amazon Cognito. So I'm authenticating, and now I'm in the application. What we've done is we've actually, to kind of speed things up, we've gone to HealthLake, we've done a get to pull back a patient and an encounter. We have those fire IDs here at the top of this screen. I also have this record button. I'm not going to hit it yet. When I do hit it, it's going to start capturing audio. And a colleague of mine is going to help go through a demo patient encounter, a really quick one. And then when that audio is finished recording, it's actually going to be uploaded to our account, and it's going to kick off the series of events that will run it through Transcribe Medical, convert that speech to text, and then we're going to run it through a Lambda function that we created. And I'll show that here in a minute to take that information, convert it to a document reference, and then we will put it into Amazon HealthLake. And then at the very end, we're going to take the results that HealthLake provides, the models that it will run on that unstructured data, and we're going to surface it back to the clinician here in the application. So I am going to go ahead now, and we're going to pretend to do a very quick patient encounter. I have my colleague here with me, and let's go ahead and get started. Hi, Harvey. Nice to see you today. How is your asthma doing?
It's doing terrible. I'm wheezing and coughing constantly, and I'm just very uncomfortable. Sometimes my sinuses also bother me, and I get headaches on occasion.
Oh, I'm sorry to hear that. Have you been doing your albuterol a lot?
I've been doing it once a day. Is that a lot?
Yeah. I'm going to prescribe a daily dosage for 10 milligrams of Montelukast, which is a preventative that I want you to take one pill every night. It should help with your breathing. Now, for your allergies, I'd like you to start taking 180 milligrams of fexofenadine every day. It's an over-the-counter medication you can get from anywhere.
That sounds great. Thank you so much, doctor. Have a great day.
So now that conversation that has been recorded, it should be uploaded here in our S3 bucket. Let me refresh. And here's the audio file. So what has happened now that this audio file has actually been generated, it will run a quick trigger for another Lambda function that will pass this information to Transcribe Medical. So if I come over here to Transcribe Medical and I look at the transcription jobs running, let me refresh this. We should see it is okay. It's currently in progress. So while we're waiting for that to complete, I'm going to head over here to Lambda. AWS Lambda is a way to run code without servers. And upon completion of that Transcribe Medical job, it's going to deliver the results of that into a different S3 bucket we have in our account. And this Lambda function will pick up that information, so it'll be triggered from it. And at some point, when this job completes, you'll actually see the application on the left update. And before we get over there, though, I'm going to continue walking through the console just to kind of illustrate a couple more things about what's happening here. Now, the first thing I want to point out is as this file data comes in from S3, we pull the results out, and we actually are going to base64 encode that text. We take that information and we package it into a JSON document reference here. So this is FireR4, and we're going to put it into HealthLake. So we're getting information from HealthLake about the encounter, as well as this encoded text, creating the document reference, and again, doing a post into HealthLake here in this function. And as you can see on the left in the application, the results have already come back. Before I jump in there, though, I want to show one more piece here, and I'm going to go into Amazon HealthLake. So in HealthLake, we have the ability to actually run queries within the console. I'm going to do a quick read of this document reference that we just created. I'm going to go ahead and copy the document reference I have over here that was generated in the application. And I'm going to run the Git now. So here's our document reference that we created. I am Dr. Brian Test. This is related to this patient here. Here's their FHIR identifiers, you'll see. And it's related to this encounter. And if we scroll a little further, you'll notice that in the content attachment data section of this FHIR resource, this is the base 64 encoded conversation that I just had with Harvey. Everything above this is what we generated in our Lambda function. Now, if I go down a little bit, you'll notice that HealthLake has added this extension. And I'll scroll slowly here just so you can kind of see some of this, what it looks like. But the results of the comprehend medical models that HealthLake has available for it, like looking for ICD-10 codes, RxNorm, PHI, anatomy. There are various other things that Comprehend Medical and HealthLake provide us here. But the results are actually appended to the same data set here. So we're not copying out of our account or de-identifying or anything. We're running AIML against the data itself here in this account. And so the results of these models, we can actually iterate over them. And so that's exactly what we've done in our application over here on the left. So this application has gone to HealthLake. It's pulling out this information and this extension, and we're surfacing it back to the clinician so that now they can make a decision on this information. So if I look over here on the left side, you'll notice that we were talking about asthma, so it is up here at the top, and we have some ICD-10 codes associated with asthma. But we were also in the conversation talking about, Harvey mentioned wheezing. And we have ICD-10 codes here of like R06.2 for wheezing, shortness of breath. And if we continue to go down, you'll see coughing was another symptom that he had mentioned. And we have headaches, and it happened today, or that today was mentioned earlier. Nice to see you today. So as we continue to look at these entities, I'd also like to call out that we talked about medications. And so it heard that we were talking about albuterol. And so here's RxNorm information related to albuterol. Same thing for Montelukast. One thing that's pretty cool here, though, if you look at these results, I mentioned 10 milligrams of Montelukast. And so it actually has here the RxNorm for a 10 milligram oral tablet. Same thing for fexofenadine. If I come down here, we were talking about 180 milligrams oral tablet. And again, we have a confidence score here. And then we've also, in our application, we went ahead and built out this other AIML results where we can kind of show in this example here, we said Harvey. So that name was detected as PHI. And there's some other things down below like conditions, medications, etc. But the idea is that by surfacing this information back to the clinician, they can now make a decision on this data. And so, for example, if in this application we wanted the clinician to be able to click a button to actually file this ICD-10 code and associate it with the encounter, all it would take is writing this back to HealthLake as another FHIR resource. So, that's the great thing about FHIR is we can start to capture this information, and all of our downstream systems are going to understand it. And so things like allergies and medications and you name it, we can continue to provide a system where this information is captured and other systems know what to expect from that information. So this concludes a demo of how to create a real-time clinical application on AWS. Again, in an AWS account that we started with guardrails in place from a HIPAA quick start. And now we've been able to go forward and build something where we've captured information. Again, this unstructured audio, we've made it interoperable by converting it to a FireWire4 resource. And it is now in our Fire server, and we ran additional machine learning against that information and provided the results back to the clinician. Thank you.
Now, as we just showed, we were able to take voice between a clinician and a patient, capture all of that, get it into AWS and make it interoperable, and then provide insights back to the clinician. And this is a really common thing we're hearing from customers today. And for example, at Houston Methodist, just this past year, they've done a lot of voice work, and especially in two areas. First, they're doing a voice in their operating rooms, where surgeons are actually able to interact with their electronic health record system by asking commands while they're in the OR. They can also do things like start and stop timers. Again, all of that built on AWS, and all that information being captured and stored on AWS. They're also doing ambient listening, where we had a partner that came in and built a solution for Houston Methodist, where, similar to that conversation between the clinician and the patient, they can actually surface that information back in real time. So the clinician is seeing the results of the conversation come in. And so those are two areas of voice that we've seen in the past year, just at Houston Methodist alone. So some closing thoughts on all of this. The first thing that we want to make sure that everyone remembers is that it is important to break down those silos. That, when we look at healthcare today and all the different silos of data across all those different places, it's hard to know how to access it, how to secure all of that. And so by breaking those silos down, you can start to be very strategic and interoperable. And when we talk about this, be interoperable, it is important that as you go forward and you build new solutions, don't just go create another data silo. Try to align on Fire when you can, and if anything, align on a common data model so that everyone who interacts with that data knows what to expect. And then lastly, most importantly, design with the future in mind. I know in healthcare, we have to stand up solutions and respond quickly so we can best enable our clinicians, so they can empower them to deliver the best care possible. But it's important, as we continue to deploy new solutions in these organizations, that we keep that future in mind, that we don't just go stand up additional data silos, but instead we focus on securing everything together and being able to provide the proper access and security controls to that data so we can go and create those real-time clinical applications. So with that in mind, I wanted to thank you all for joining us today. It was a pleasure getting to speak to you. And if you have any questions at any time, please feel free to reach out. Our contact info is, you can find us online, and you all have a great day. Thank you.